Hello, everyone, and welcome to the first session of the day. I'm Anubhav Gupta with my co-speaker Deepanshu. We are from Gojek, and today we'll talk about how we measure mobile application performance at scale. There are three takeaways from this session. First, we will discuss how we defined application performance metrics. Next, we will discuss how we designed data pipeline and observability. And at the end, we will talk about page performance scoring system. So let me begin by giving you some background and insights about Gojek. Gojek is Southeast Asia's leading on-demand platform and a pioneer in multi-service ecosystem model. So we offer a wide range of services like mobility, food delivery, and logistics. Gojek operates across main cities in three Southeast Asia countries, Indonesia, Singapore, and Vietnam. As of September 2021, Gojek has 2.5 million driver partners and more than 1 million merchant partners. In Gojek, in 2020, Gojek contributed 250 trillion Indonesian rupiah to the national economy, which is equivalent to 1.6% of Indonesia's GDP. From the engineering perspective, we also run one of the largest JRuby, Java, Clojure, and Go clusters in Asia. We process more than 350 million internal API call per second. And we also love to contribute back to the community, and we have open sourced many of our tools and libraries. You can check them out at Gojek's GitHub page. Now, you must be wondering what is the importance of mobile app performance, right? So we found some research and data on the internet from various sources. The data can be categorized into three main categories. So first category is user experience, right? A 2021 study by AppDynamics found that 93% of the users expect reliable and consistent performance. A 2015 study by Dimensional Research found that 49% of the users expect app to respond within 2 seconds or less. Second category is customer retention. So Dimensional Research study found that 55% of the users will hold your app responsible for poor performance, not their device or network. And App Dynamics survey, 63% of the user actively try to discourage others from using your service or brand if they have a digital bad experience, right? And the third category is business growth. According to the App Dynamics research, the percentage of users willing to pay more for an app that outperforms its competition grew to 50%. So based on these numbers, it's clear that app performance is one of the most critical factors for delivering a delightful mobile experience to customers and ultimately for the growth of business. So what are the metrics we use for measuring mobile app performance, right? We have categorized into two main metrics. One is the app launch time. This is the first user experience that user sees when opening the app. It is a time they need to wait before the app is ready to be used. This app launch time is very critical because a long launch time will delay the users in performing a task, which may frustrate the user. And second is page performance. It is the performance of the screen in customer journeys. It can be divided into two sub-metrics, initial and post-load metrics. So next, let's discuss about these two sub-metrics. So how do we define initial page load time? It is the amount of time taken for a screen to render the content and become interactive to the user. So it starts when user navigates to the screen until the first meaningful content is rendered and interactive to the user. We have called this time as time to initial load, or you can shortly called as TTIL. We can break TTIL into several granular metrics within the timeline, right? So first is dependency injection. This is the time taken to resolve and inject all the required dependencies for a screen and its related components like view model, presenter, and many more. Second is time to first layout. It measures the time taken from screen initialization until the first layout content is rendered. Usually it is shimmer or any view that represents the intermediate loading state. The third is content fetch time. This is the time taken to fetch the content from network or the local disk. It includes the time taken to decode the raw data into data object as well, right? And finally, content render time. This is the time taken for the view to render the content itself. And in addition to the initial page load metrics, we also measure post load metrics as user interacts with the page, such as scrolling, doing animation transition, or tapping of a button. We divided it into three submetrics. First is slow frame. This metric is the percentage of the screen instances during which user sees 50% of the frames having a jank. Basically, the frames took 16 milliseconds or more to render. Second is frozen frame. This metric is the percentage of screen instances during which more than 0.1% of the frames took more than 700 milliseconds to render. And the third is image load. So most of the app are image-rich apps. So we measure the image load as well. So it basically define the time taken for an image view to request for an image from server or cache until it is converted to bitmap and displayed to the user. We also include attributes like response size, request width, and height. Next, let me hand over the presentation to my co-speaker, Deepanshu, who will take it further. Yeah.
Thank you, Anubhav. Hi, everyone. This is Deepanshu, and I'll be taking forward from here. In the previous slides, Anubhav has explained what all metrics we use for measuring mobile app performance. Now, let me take you through how we capture these metrics and design the data pipeline flow so it can be monitored from a dashboard. As you can see in the diagram, the mobile client first captures traces using Firebase Performance SDK. Next, Firebase performs a daily batch export containing all raw data to BigQuery. Then we use Gojek's open source tool Optimus to schedule a daily job to aggregate raw data into summary tables in BigQuery for data warehousing. And finally, we use Grafana dashboard to query summary tables and display the performance metrics for our stakeholders to access and monitor. Let's dive into each of the steps in the next slides. For mobile client tracing, we utilize Firebase Performance SDK's custom tracing feature. To minimize the performance impact due to trace collection to users in production, we use random sampling to decide whether we should collect the trace or not for a particular session. Firebase SDK also provides built-in automatic capturing for frozen and slow frames for an activity or fragment on Android and UI view controller on iOS. In addition, it also captures traces from the network API calls for both platforms. Next, let's talk about data aggregation and warehousing. As we build a custom unified dashboard to display our metrics, we need to export Firebase performance traces into a data source which we can use to query. Firebase provides BigQuery integration that will run a daily batch job for exporting all the traces to the BigQuery table. At our scale of users, querying the raw data directly from this table is very costly and time consuming as the data is quite large. To avoid this huge cost and query time, we utilize Gojek's Optimus for data transformation and warehouse management. We simply need to write queries to aggregate and batch the raw data into summary tables and schedule the job to run on a daily basis. We aggregate the traces using percentile scores from P50, P90, and P95. Using percentiles provide a better visualization on how the numbers are distributed across the group. The next part is dashboarding and monitoring. For the dashboard, we use one of the most popular open source dashboards, Grafana. It provides a wide range of built-in graphs that we can use to visualize the data over a series of time. Grafana itself doesn't provide BigQuery as the data source out of the box, but any data source can be added using a plugin. We use the official BigQuery plugin from .intel to add BigQuery as the data source so we can write row SQL queries to retrieve the data from BigQuery. For alerts, we define the base threshold for each panel and use Slack to post the alert in case the value has exceeded. We deployed this dashboard internally so it can be accessed by our stakeholders. Let me show you the illustration for the dashboard panels in the next slides. This is the payload time dashboard, also known as time to initial load TTIL, for a screen. It shows three lines representing P50, P90, and P95 values of page load time for a particular screen. Next is the dashboard containing the granular traces such as dependency injection, time to first layout, content load time, and content render time. Here we have the dashboard for screen responsiveness showing panels for frozen frame ratio and slow frame ratio of a particular screen. Finally, we have the image load dashboard showing panels for overall time taken to load an image, time taken to get an image from disk cache, and time taken to fetch an image from network. We also have a panel for showing the response size of images for a particular screen. Next, we would like to talk about page performance scoring. Page performance scoring is a scoring between 0 to 100 that we use to measure overall performance of a screen using multiple metrics from real users in production. PPS uses multiple metrics like TTFL, TTIL, slow frames, and frozen frames, calculates the score given the formula and weights each metrics into one single score. This page scoring system has been used by other apps as well. For example, Airbnb published a blog detailing their page performance scoring system. The underlying mechanism itself is quite similar to Google Lighthouse for measuring the performance and quality of web pages. For each metric, we calculate the data into a single score from 0 to 100 using log normal curve distribution. We simply define the median control point and P10 point using the threshold that we want to achieve. And uh, after we get the score from each metric, we sum the metric into one final value based on the weight of each metric. Here we have the dashboard for showing the page performance score. We have panels for the latest value, weighted score distributions, and the score history over a series of time. Now let's talk about the benefits we have gained so far by performing this exercise. With the measurements, we have been able to understand the performance data for our current users. It helps us to set the baseline and thresholds going forward as we add improvements. As we add features to our app or release a new app version, we are able to catch any performance regressions as soon as the app is released. Also, we are able to monitor improvements made in new app releases. With the data available in our BigQuery tables, we are also able to archive the data for long periods of time. So what's next in our pipeline? The current way we aggregate the data takes a couple of days to be reflected in our dashboard because Firebase takes around 24 to 48 hours for exporting the data to BigQuery. So we want to make this monitoring real time. We plan to achieve this by using Clickstream, which is an open source tool maintained by Gojek for real time analytics data ingestion. Finally, we want to make the performance measurement as a part of our CI/CD pipelines so we can catch performance regressions early during the development lifecycle. That's it for this session. Thank you everyone for watching, and now we can take questions.
Thank you, guys. That was very informative.
Thank you.
Okay, we can now receive questions. If anyone has a question, please send it now. You can post your questions in the comment section. Okay, we have some people saying that it was nice. Thank you, guys. Any questions? Okay, we
I
have one
think there
here.
is, yeah,
Yeah. Max says, how do you export metrics for now? By hand, daily? He's asking, is it done by
Yeah.
hand?
So as we talk, so we use Firebase for sending the metrics, and we use Firebase. There is a feature provided by Firebase to export the Firebase tracing data to BigQuery. Right, we can enable that export from the Firebase console, and then from there, what we do is we write Optimus jobs to summarize that data, and by summarizing the after summarizing that data, and then we put it into a summary tables, which we actually query to show the metrics on our dashboards. So yeah, this is all automated, so we don't have to do it manually.
Okay, great. Here's another one.
Yeah, next question is BigQuery necessary for the populating the graphs, or you can use this performance app performance? Yeah, thank you for this question. So yeah, we use BigQuery because if we directly query the Firebase performance data, that is actually very huge, and the queries will take a very long time to render the data on our dashboards. So yeah, we use BigQuery. So from the source tables to the summary tables, we aggregate the data and we use those summary tables to show the metrics on our dashboards. Yeah, Anubhav, would you like to take the next question? Is,
Yeah,
is Firebase dashboard?
Uh, okay, sure. So yeah, so we can use Firebase dashboard, but there are two basically motivations for using a custom dashboard, right? First of all, we want to segregate each of the metrics into customer journeys, right? So using the Firebase dashboard, I don't think it's possible, right? We have tried that, but we can't make customer journeys panels, right, for each of the customer journeys, right? So that's one. The second thing is key, you can add the custom traces, but you will need to search for every time, right? So and that thing, right, searching custom tracing for every time might be easier for the devs, right? But for other stakeholders like product managers or executives, right, or a QA team, release team, right, might be very time consuming, right? So what we want to achieve is we want to achieve a one-stop dashboard where any stakeholder can easily log in and view the performance that is there, right? The third thing we wanted to achieve is eventually, right, we wanted to move away from the Firebase, right? So Firebase, why are you we using Firebase is it's a easier mechanism to test out this MVP, right? Eventually we want to move to clickstream, right? As we talked about, this is a real-time ingestion by Gojek, right? So we can ingest the performance data in real time and monitor those on the dashboards, right? So using those dashboards, what we can do is we can monitor the regressions, right, or improvements, and take the rollout decisions as well, right? And when we do an app release.
okay, great. So Kennedy asks, do you need support from other teams to set up the analytics pipeline?
So yeah, so thanks for asking this question. So Gojek has bunch of um, Gojek is part of the open data platform, right? So there we have bunch of open source tools. Like one of them is the Optimus, right? So uh, you can take a look at that, but these are heavily integrated within the Gojek ecosystem, right? So uh, as a user of those tools, right, we didn't have to do much within Gojek, right? But if you are using something else, right, for data ingestion, you might need some work or you might need to take help from other teams, right, data teams for ingesting the data into proper format or in summary tables.
Okay, great. That leads us to the next question from James. Is there a sample project?
Right now, there is not one. but that's a great idea. We can definitely look to create one.
Okay, great. Um, uh, you have event-based triggers in Firebase. I don't know if it's a statement or a question. Do you have something to say about it?
Uh, if your question is ki we are using Firebase for events, right? Currently, we are using, but shortly we will migrate to clickstream-based event ingestion, not Firebase.
Okay. So our last question is from Raksh. What is the overall estimate cost to set up everything, starting from Firebase to Grafana, from 1 million daily active users?
Yeah, so the cost, right? The main cost is the BigQuery export and the query, right? So that will depend on your project, right? So if your project uses flat pricing, the cost will be different. And if you are using a different costing model, right, for the BigQuery, your costing will be different, right? So I will suggest that you talk to the relevant teams in your company, right, and discuss about the costing model for the BigQuery, right? So that will highly depend on that. The next question is, did you guys face any overhead problems with Firebase performance release on overall project? Uh, we did not, right? We basically are using Firebase performance for a long time now. But uh, to not overload the performance data, right, for everyone, right? So we use a random sampling for the users, right? Right. So not all the users will send the performance data every time. It is based on random sampling, right? So some of the user will send uh, tracing data for some of the sessions.
Okay, great. I think that sums up all the questions. So thank you, Anubhav and Deepanshu. This was a very, very interesting and informative session.
Thank you.
Thank you.
So